Hi friends, I hope you are doing well. Welcome to my channel once again. As I told, every week I am uploading one video related to the medicinal chemistry or organic chemistry. In the future, I will try to decrease the duration of these videos, uploading the videos. Please cooperate with me and try to subscribe the channel, and I am sharing the description of the notes also, which is available in the Telegram. I hope you will be find everything well. Okay, we'll be start about today's sedatives and hypnotics. We might be now I think when we make on our video, our brain is working very sharp. It's working sharp up to that extent it is good, but it is working more than the limit. That's very bad for our health. At that time, when it will be more than the limit, it is working our brain more than the need, then we needed the sedatives and hypnotics. Then what is the definition for these sedatives and hypnotics? Especially the sedatives, no drowsiness they are going to be produced and no sleep, but causes depression of central nervous system. Sedatives without causing drowsiness, and without causing sleep, they are going to be produced or they are going to be mildly depress the central nervous system. That's called as the sedatives. In another word, the hypnotics. This hypnotic, it causes both produce drowsiness and as well as produce. See the difference. The difference is very minor here. बहुत छोटा सा difference है. When you see, one it is causes no drowsiness, no sleep, sedatives, but mild depression of the central nervous system. थोड़ा सा डिप्रेस हुआ तो थोड़ा सा डिप्रेस किया तो क्या होता है? Then we will be look little bit calm. थोड़ा सा खामोश रहते हैं. इसको डिप्रेस किया तो नहीं तो ये ओवर एक्टिव रहे तो क्या होता है? कभी इधर देखे कभी उधर देखे. Sometimes we are scolding to someone, sometimes we are shouting on someone. We'll do all unwanted things only, and it produces more headache, more workload. Many reasons are there. Stress, mental stress. For reducing that, it have to be causes the depression of central nervous system. Both they are causing same. दो भी same use करते हैं. The difference is the one is no drowsiness, no sleep. Another one, hypnotic, produces the drowsiness and forced sleep it is going to be produced. You don't want to be sleep, but it produces the sleep. But you might be these drugs are not freely available in the market. Without prescription, no physician it is going to be provide. Remember that. Okay. Now, what type of drugs are there? Sedatives and hypnotics. Will be have the many classes in this case. The first class will be the barbiturates. The second class will be the benzodiazepines, alcohols, aldehydes, ketones, uridines, miscellaneous. These classes of the drugs are available in case of sedatives and hypnotics. Okay, alcohols also, aldehydes also, barbiturates also, benzodiazepines also, ketones also, uridines and miscellaneous. All these drugs with examples available in the notes. Barbiturates, phenobarbital, pentobarbital, secobarbital, thiobarbital, thiopental sodium, all this will be comes under in the barbiturate. Next come to the benzodiazepines. Diazepam, more popular drug. Clonazepam, that the different of drugs are there. Okay, then alcohols also there. Aldehydes like paraldehyde available in the market. Then ketones also there. Uridines also there. Okay, all these classes comes under in the sedative and hypnotics. Here, sedative and hypnotic, already I told that minor difference is there in the dose. Small dose, it causes sedatives. Medium dose, it causes hypnotics. Large dose, it produces the anesthetic action. What? Repeat once again. Small dose, sedative. Sedative means no drowsiness, no sleep, but mild depression of the central nervous system. Hypnotics produces drowsiness and forcing us to sleep and causes mental calmness. And you might be saw general anesthetic. They require the large dose. Dose is large, heavy dose. That is the dose difference. When they will be act as sedative, when they will be act as hypnotics, and when they will be act as the general anesthetics. I hope up to this extent you understand. Now I will go for the barbiturates. I will write the general structure of the barbiturates. This is the general structure of the barbiturates. Barbiturates, they are derived from the barbituric acid. These are all the derivatives. ये कहाँ से आते हैं? Barbituric acids. Here nothing is there. Only the two hydrogens are there. Like this. This is called barbituric acid. Barbiturates, from where we are getting? Barbituric acid. Then why we require the barbiturates? Already we have the barbituric acid. It means here barbituric acid, it won't produce any action on central nervous system. It means it is not active drug, barbituric acid. It won't have any biological action. Reason? What is the reason for that? Barbituric acid is more hydrophilic. What? More hydrophilic. That is the reason. It cannot cross the blood-brain barrier. Inside blood-brain barrier is there, where the lipid solubility will be more. Okay, hydrophilic compartment, lipophilic compartment, both are there. The drug have to be reached to the central nervous system means what? It have to be cross the, it have to be cross the blood-brain barrier. For crossing this blood-brain barrier, the drug should be, what type of drug will be required? Lipophilic. Remember what we required? Lipophilic. If it is hydrophilic, it is not going to be cross. It is not going to cross blood-brain barrier. No crossing blood-brain barrier. It is not going to reach the central nervous system. No use of that drug. Remember that. That's why barbituric acid, it won't have any sedative and hypnotic action. That is the reason. Remember, that is the reason we are going to be modify this barbituric acid to produce more biological action to cross the blood-brain barrier. It means what? Hydrophilicity we have to be decrease. It is more hydrophilic. Hydrophilicity we have to be decrease. Then what we have to be increase? Lipophilicity we have to be increase. Then easily it is going to be cross the blood-brain barrier. That's why we have to study about the structural activity and relationship. What is the relationship between the structure and activity? See how amazing this one. One is crossing blood-brain barrier reaching to central nervous system. Another one not crossing the blood-brain barrier. No use. Not crossing, no use. Then we'll go for the SAR next. SAR next. This is the general structure. I will write as the R1 and R2. Then give the numbering for this. Always the heteroatom should be how to get the lowest possible number. 2 heteroatoms, nitrogen, nitrogen. You can go from this way or you can go from this way. Okay. Then I will go from this side. 1, 2, 3, 4, 5, 6. Now see, for producing the sedative and hypnotic action, R1 and R2, fifth position playing the vital role. Remember that. Fifth position playing the vital role, because fifth position only responsible for increase the activity, to show the activity, because it is going to be changed this position, specially the lipid solubility of the drug. What it is going to be changed? Lipid solubility increasing. Then it causes, because this is the barbituric acid, no substitution means that is hydrophilic. More hydrophilic, not going to be cross the blood-brain barrier. Balance should be there between the lipophilic as well as the hydrophilic. That's why what we are doing in the SAR, we are structural activity relationship. In that, specially we are concentrating which substitution here going to be produced, what type of difference in the activity. We'll go here one by one. Now see, in this case I given first position, second position, third position, fourth, fifth, sixth. Here you might be observing at the first and third position, what are there? Nitrogens are there. In the 2 nitrogens, one of the nitrogen you can substitute any one, because here one hydrogen, here one hydrogen is there. Any one you can substitute, either this, only one, because one is required for the protonation of the ionization of the drug. When after crossing the blood-brain barrier, both you are going to be substitute, means decreases the sedative and hypnotic activity. One only you are going to be substitute, means it is going to be increase sedative and hypnotic action, increase. How it's we cannot reach to the imagination of this also. How the difference, minor difference here. For example, you can see here, this hydrogen, if I will be replaced with the methyl group, what happen? Sedative and hypnotic action, onset of action increases, but duration of the action decreases. Onset immediately after taking produces immediate action, but what happened? Duration, that is the length, long time, it is going to be decreases. See the difference, how dramatically it is going to be changed. But only one nitrogen, hydrogen only we are have to be substitute or replace. Now you can see this second position play the vital role there. This oxygen we can replace this with the sulfur. Replace with the sulfur means more onset of action, more activity, fast, dramatic, 100 times the activity it is going to be increased. But here same again, but duration of action decrease. Again same, what decrease? Duration of action, it is going to be decrease. What we did here? Activity will be more, but the duration will be less. Then comes to this position, either 4th position or 6th position. These oxygens you cannot be replaced. If you replace, you might be thinking one sulfur, more activity it produces. I will add another 2 sulfurs here also. Never. Never. That is not going to be increase the activity. Instead of that, it decreases the activity. See, everything have the limitation. It should not be cross the limitation. 1, it is good. Okay. 2, it is ineffective. How it will be? If you have the 1 kit, anybody have the 1 kit, he can serve more. Even financial things also. Even he can give good education also. If 2 or 3 or 4 kids, एक बच्चा जाके 4 बच्चे हुए तो क्या होता है? सेम पैसा दे पाओगे, सेम एजुकेशन दे पाओगे उसको? Never. We are not going to be give the same. That is the reason 1 sulfur is good. All oxygen, if you are going to be replaced with the sulfur, means activity decreases. Now see this important position, 5th position. On this 5th position, you can write even 10 SAR points also. At this 5th position specially, what I told, R1 and R2 here. For example, R1 is aliphatic chain. R2 should be aromatic. One is aromatic means another one should be aliphatic. Both cannot be aromatic. Remember, both R1 and R2 at the 5th position, both they cannot be aromatic. One is aromatic means another one aliphatic. But both they can be aliphatic. Both they can be aliphatic. But when aromatic group will be there, for example, R1, I can, for example, R2, if I will be substituted with benzene, here I will be substituted with the ethyl, the activity it will be more compared to when both should be aliphatic. This one also aliphatic. For example, I will write here once again. See, one is aromatic, one is aliphatic. For example, both they are aliphatic. Here I will write CH2, 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 CH3. Here I will write CH2, CH3. And one more CH2, CH3. One more CH3, CH2. Total how many carbons here? 5 plus 2. Total 8 carbons. Here how many? 6 plus 2. Total 8 carbons. Both they are having the 8 carbons only. But which is more activity it will be have means this one more active because this aromatic ring. How the difference in the activity it is going to be produced? In the same manner, just see, I am discussing about the 5th position only. If in this side chain, the side chain particularly, or number of carbons will be more, means what happen means more number of carbons, what they will be generally they can do means increase the duration, increase onset of action, increase onset of action, but decrease the duration of action. When it will be having the more number of carbons. Remember, when it is having more number of carbons. See, here also number of carbons are 8. Here also number of carbons are 8. But the difference is what? Here aromatic ring, here the aliphatic ring. That's why this is more active. Understand? Then here something very zigzag. I wrote more. That's why what I will do, it will be clean. I will write here. One more I will write here. See, next, if it is in the, particularly in the side chain, any double bonds will be available. Any double bonds present, easily it undergoes the oxidation. What? Oxidation. That's why what happened? The activity, particularly the duration of action of the drug, duration of action decreases because it undergoes oxidation. If for example you might be thinking in this case it have the more branches, more branches decreases duration. Less branches, if you might be think here no branches, increases the duration of action. See how much difference is there? Branches decreases duration of action, no branches increases the duration of action, but here the branches increases the onset of action. Opposite, onset of action increases, but here onset of action decreases. See the difference? Okay, that's why what we have to be do, if we want more action, onset of action, we have to increases these branches, but easily they undergoes the oxidation. That's why the duration of action will be decreases. Drug duration, for example, it have to be work, if onset of action will be more means it will shows its action in 5 minutes. If duration of action will be more means what happen, that action will be persist for half an hour or 1 hour or 2 hours. The duration of action, long time action, how much time the action will be required, 5 minutes, 2 minutes or half an hour or 30 minutes or 1 hour. That depends on this side chain. Remember that. In this case I will give one idea for you. What happen exactly means, the number of carbons together means both R1 and R2 at fifth position should be more than 4 to produce what? Sedative and hypnotic action. More than 4 but less than 10 to produce the same action. If less than 4, if it is less than 4, no action. If it is more than 4 also, no action. Remember this, the number of carbons together both the positions from 4 to below 10, then only it produces sedative and hypnotic action, otherwise no. See how the SAR, very interesting, no? I hope so. Okay, if 4 carbons are there all together both the positions, what happens? What it will be produces? Long duration of action. Long duration of action. Long, very long. Because less number of carbons, long duration, because no oxidation. If what happens here? If number of carbons 7 or 8, what happen? Easy undergo oxidation. That's why less duration of action will be decreases, but onset of action will be more. If the total number of carbons are 5, intermediate, even onset of action, duration of action. I hope you might be enjoyed the SAR of this sedative and hypnotics. Remember, the important position is the 5th position as well as the 2nd position. 2nd position I told sulfur like thiopental sodium, ultra short activity, lipid solubility increases more. That's why biological activity also increases, but the duration of action will be decreases. We have to be remember. Okay, but here you can remember one aromatic, another one should be aliphatic. One is aromatic means, otherwise both they should be aliphatic, but the aromatic will be have the more activity. I hope you might be understood the SAR. Thank you very much. Good boy. Okay, next class we'll go for the benzodiazepines.